who had MS herself. She read the research, and she said, I think this will work. I'd like to give this to several of my patients. So I said, well, make me the guinea pig. So I went to, now I had done all this research. In '94, I was still using the adenosine monophosphate in the B12. I believed in the research, but you know what? Hey, I don't want to rock the boat. I'm doing okay with the adenosine monophosphate in B12. In the fall of 1996, my employer made all the nurses get a flu vaccine. I had always stayed away from those. I didn't want to do those. I got the flu vaccine. I got very ill. From that point on, the adenosine monophosphate in B12 quit working for me. Okay, you've done all this research. It's time to walk the talk. So I found this neurologist, and I asked her to, make me the guinea pig. Let's try it. This was early part of 1997. She said, I think this will work. I want to do this. So I transferred my records over to her, made an appointment the day before I was supposed to go in and get my first, start at the time I was going to just start it as an infusion, as an injection. And she called me up and she said, I can't do it. And I said, why not? And she said, well, we're a large conglomerate, and so I had to go to the legal counsel, and they said no. And I said, didn't you argue the risks versus the benefits? I said, histamine diphosphate has been around for years. It has been used all the way back from 1911. It's a cure for Meniere's disease, all these things. She goes, yes, she said, I did. And I said, and it's approved as a gastric acid test for pernicious anemia. We can test that simple now. So the risk versus the benefit, and she said, I did, but they won't let me do it. Well, anyway, this kind of repeated. I went to doctor after doctor. Finally, my general physician said, so to him, and he said, yeah, this will work. So I started it, got it worked out, started first as an injection of just the histamine phosphate. The only trouble was the symptoms would, you'd give an injection, but the benefits of them would only last about 2 hours. So then I had to, keep giving an injection every 2 to 3 hours. Well, I remembered I wanted to keep that cyclic AMP. Remember, I wanted to get that cyclic AMP up, which is one of the things histamine 2 does. Well, histamine is very rapidly absorbed and metabolized. So I wanted to maintain the effect. So I added a little bit of a phosphodiesterase inhibitor to it. Phosphodiesterase is the enzyme that breaks down cyclic AMP. So I thought, gosh, if I can just inhibit that just a little bit and keep that phosphodiesterase up, it'll probably work. So what's a good phosphodiesterase inhibitor? Caffeine. Very common, been out there for years, very safe, large therapeutic index. So I added caffeine to it. Voila, it worked. With that, I could get an injection to last 8 hours. Now, the only problem was the caffeine was not tissue friendly, and it was causing abscesses under my skin from the injection. So I thought, oh, you know what I got to do? I got to get it in a transdermal cream, something that will just slowly release it across the skin. So I found a compounding pharmacist, and she worked, and that's how I eventually came to the Procarin, making this transdermal cream, which is histamine diphosphate, caffeine citrate, in this certain particular cream that keeps that histamine in that H2 form and just slowly releases it across the skin by a patch. So now you just take what works, and you've done studies on yourself for how many years? Well, I've been on the Procarin for 8 years. Now, I'd been on it, it started working for me. This transdermal cream was working great. I went and had labs done. All my labs were getting better, and so I knew it wouldn't hurt me. So then I thought, okay, if I can't get a doctor to do this research, I'll take it to a pharmaceutical company. Surely they'll see it. So the first one I went to was one here local in Bothell, Icos Pharmaceuticals. Now, at the time, they were working on monoclonal antibodies for MS. And so, I took my research to them. First off, when I called them, their very first words out of the business development department said, look, if you're talking about a treatment that works on the animal model of MS, we're not interested. We know what works in that doesn't work in MS. Well, I told them, no, I wasn't. I'd done this myself. But I was kind of taken back because here they were purporting that their monoclonal antibodies were going to be so great with MS based on what it did in the animal model. And I'm like, okay. So you say one thing, but no differently. So anyway, I sent my research to them. They looked at it, and they said, we think this, they sent it back, and they said, we think this will work in MS, but we're not interested because we don't think it's patentable. So, okay, fine, I'll take it to a patent attorney. So I went to a patent attorney and I said, what do I got to do? A drug company won't look at this unless it's patentable. What do you think is patentable? Well, that's when I learned there's two different kinds of patents. There's a molecular patent and there's a utility patent. Now, drug companies want the molecular patent. Why do they want a molecular patent? Because they hold it close to their chest. They're the only ones that have the recipe on how to make the molecule. And furthermore, when you get a patent for a drug, you get it 20 years from the day the patent application, or 17 years from the date of issuance, whichever is greater. And so it takes many years it takes about 4 years to get the patent, and then several more years to get through the FDA approval and all the things you have to do. And so by the time the drug gets out there, there's not a lot of patent life left. And it costs you, now drug companies try to make us think that it costs anywhere from $300 to $800 million to get a drug through FDA approval, and that the odds are only 1 in 500. Well, it costs anywhere from $300 to $800 million to get a drug through FDA approval.
It takes $300 to $800 million to get FDA approval on a new drug.
If that were really true, how in the world could it become a multi-billion-dollar industry with those kind of odds and that kind of cost? It doesn't cost that. They make us believe that. They inflate the cost. It costs about $20 to maybe $50 million max to get through the FDA approval process. But anyway, they like a molecular patent because first off, they own the molecule, right? Now, you can't make a molecular patent off a naturally occurring molecule. It has to be a synthetic molecule. You can't, if it already occurs in nature, you can't. Yep. Well, so they like molecular patents because they own it close to the chest. And at the end of the 20 years, when that molecular patent is up, then they like to make an isomer of it. Just tweak it a little bit, use it for the same indication. Well, now this is why all of our drugs cause so many side effects. Pages and pages of side effects. Why? Because remember those receptors that are on the outside of the cell? Those are naturally occurring receptors. They're very, very specific. They will only let a certain key open them up. And then they turn it, and the little cyclic AMP runs and does its thing. They're very, very specific. So when you make a synthetic molecule, and because they're naturally occurring, for the most part, it's just going to be a naturally occurring molecule that's going to turn them. So if you try to make a synthetic one, it's probably not going to be a good enough fit to turn that key. All it's going to do is plug up the hole and not let the real key in. And this is why all of our drugs are what we call blockers or antagonists. They block that receptor. That's why we have calcium channel blockers, potassium channel blockers, we have beta blockers, we have serotonin reuptake inhibitors, blockers, the same thing. Histamine 2 blockers, we have antihistamines, which are H1 blockers. Almost all of our drugs are blockers. Because at the end of 20 years, this molecular patent, they can take and tweak it a little bit, make a little isomer, put a little extra bump on that key, and it won't work, just blocks it. And so they get a 20-year patent after 20-year patent after 20-year patent, and it's a very quick, process through the FDA approval process from that point on, because you're just saying, well, here, I've got all this old data, we're using it for the same indication, but we tweaked it a little bit. And so you get an FDA approval process very quickly. So they like molecular patents. Now, Procarin, because you're using histamine phosphate, is a utility patent. It's a histamine diphosphate's been around for years. The patent is worn out on it. Caffeine's been around for years. Patent's worn out on it. So you're saying, I'm going to use either an old drug that the patent's worn out on or a naturally occurring molecule for this indication. You're only going to get one 20-year patent. So that's not very enticing. But furthermore, you're using something that's already readily available out there. So that drug company goes and spends the money, gets it through the FDA approval, gets all this interest in it, and then it's hard to police because people can take and, pirate your stuff. It all just comes down to which one can make more money, which one can sell better on the stock market, etc.
Comes back to the dollars, which kind of brings us to the orphan drug status and how it ties into another myth of MS. Let me ask you, how many MS patients are there in the United States?
Well, if you ask the National Multiple Sclerosis Society, they'll tell you 400,000.
Myth. There are only 400,000 cases of multiple sclerosis in the United States.
And they just upped it from 350,000, which they've been holding that for years and years, to 400,000 in 2004. But you go to Montel Williams and Nancy Davis, who paid the Zogby International company to do the survey, they came up with 2.87 million people. Why the big discrepancy? If you were a foundation for disease, wouldn't you want to, if anything, exaggerate your numbers to increase awareness?